Hello students, today's our topic is corrosion-resistant steels and the alloys, right? The discipline is material science, and first we'll talk about the stainless steel. So what is the word about, and let's understand this word, we'll talk about the here. So it's commonly referred to stainless steel, right? It's an alloy to steel that is resistant to corrosion in the atmosphere and corrosive environments, right? In 1821, Michael Faraday and the peer noted the ability to chromium iron alloy to resist active corrosion. Because scientists were not yet aware of the rule of low carbon content, they were unable to produce an alloy with a high chromium content. In 1930, Harry Beerley, who had been experimenting with different types and properties of alloys, discovered the ability of high chromium steel to resist active corrosion. And we have the figure like how this figure works and how to see the this figure. I mean, so and the secondly presentation will talk about the corrosion resistant steels and alloys. Okay, so it's like the stainless steel, right? Its metals and alloys are metal and alloys, which the corrosion process develops at low rate. And corrosion resistant steels are used for the machine, right, and equipment parts and structural elements operating in different aggressive environments. It's like we have for instance, humid atmosphere, seawater and acids and solutions of salts, alkalis, metal melts, and essentially. Actually, we have here a lot of the experiments where examples here of the metals, and depending on the chemical composition, I mean, of steels and alloys are divided into classes by the main constituent element. It's like we have a lot of parts here. The first is chromium, and chromium nickel, chromium the others, right? And as well as the nickel-based alloys, depending on the structure, ferritic, and the how to say, we have the three parts here. So first we have talk about the ferritic, and second it's the martensitic, and third is the authentic, right? Okay, and we have the here figure. It's like the name is corrosion-resistant steels and their alloys, right? Okay, so next is the chemical composition. Now we learn about the chemical composition. It's like the how to use in the material science, right? It's like the how to works here. Okay, so the main alien element is corrosion steels is chromium with a content of 20 and 30%. Iron and chromium form a continuous series of solid solutions, as well as intermetallic the phase, and chromium with the carbon forms carbide is more stable in comparison with cemented as well as carbide CrC3, yeah. And we have the here figure. It's like the how to work in this figure, like chemical composition, and we have the here degree and the persons. It's like the 0.4, 0.2, and 0 and 0.2 and the 4. Yeah, it's like the temperature. It's like the 2 of 0 to 50. Mm-hmm. Okay, so then we have the figure shows like that the within 20 and 30% here, it's like the chromium. There is a jump like change in the electrode potential, and it still goes creation of a group of steels with 30%. Yeah, for example, we have the here chromium 07x 30 and 20x 30. We have the here at the 0 to the 40 degrees, right? Mm-hmm. So, and all these steels suffer from intergranular corrosion. The formation of the carbides consumes a lot of chromium for 100% degree and 20% chromium. Yeah? This inevitably leads to the decrease in the concentration of chromium in the zones adjacent to the carbides, and the zones enter the active states. Mm-hmm. Okay. Then we have to talk about here production and applications. Okay, according to the International Stainless Steel Forum, the world stainless steel smelting volume in 2009 was 24,079 chromium stainless steels. We here, it's like the hydraulic press valves, turbine blades, fitting for cracking units, cutting tools, springs, household items, chromium nickel and chromium demagnetized nickel stainless steel, and household items, particularly tableware, food grade steels, and we have here about the fabrication of sleeves for stamped crowns. and about the authentic stainless steels. Yeah. So we have here like figure. It's like the welded apparatus operating in aggressive environments. And products operating in high temperature, it's like the 550 and 800%, right? It's like the degree. And we use actually the food industry. Francing, yeah, and the stainless steels are used in both deformed and cast condition. So, and now our topic is ended, and I hope in the next lesson we'll talk about this and how this works. Okay, so see you soon in the next lesson.